Okay, so my notes for this section are the same as some of my notes from the prior sections, which is that some texts or websites that you use will not distinguish between the amortization or mortgage version of these formulas and the present value annuity formula, since they are actually the same formula, just solved for either P or big R. So I don't care which formula you use overall, as long as you pick a formula, an appropriate formula, and you solve correctly. But we're going to practice one last time choosing the, quote, easier formula to solve one more of these types of problems. So in this case, we have a group of investors loaning $2 million to purchase a condominium complex. The loan is to be repaid in 15 years at an interest rate of 5% per year compounded quarterly. The question is to find the quarterly payment. So based on that, quarterly payment, so those reoccurring payments are the big R's. So based on that, I'm going to use the amortization or mortgage payment version of this formula. The principal is $2 million, the time is 15 years, the rate is 0.05 for 5%, and our M compounding is 12 times per year. So I'm going to go ahead and set that up. So we put our 2 million, which is a 2 with 6 zeros, times 0.05 over 4 on the top, and then a big bracket on the bottom, 1 minus, a open parenthesis, 1 plus 0.05 over 4 inside that parenthesis set to the negative, negative 4 times 15 power, and then close it up. So what I've done is I've already put this in our calculator, in my calculator, to save us a little bit of time. You can follow along. I did it in 2 steps. I did the numerator first and got $25,000 there. And then I divided by all of that denominator in a giant set of parentheses. And I got $86, it looks like, cents. And that sounds kind of crazy. But remember, they're doing this only every quarter, so every 3 months, so the payment's going to be big based on that. And also, this was a $2 million loan. There was no down payment, so these being kind of outrageous does make sense. Now, Part B says, what if they're able to find a loan for the same amount at a lower rate, so at only 0.045%, but compounded more often, compounded 12 times a year? What would that monthly payment look like? So we're still looking for a reoccurring payment. So we're going to use the exact same formula. We're just going to switch out some of the numbers. So it still starts with the $2 million as the P, but now we have 0.045 over 12 as the fraction that we're using everywhere. So I'm going to set up the denominator again the same way I did first, just replacing the 0.05 over 4 with a 0.045 over 12. And then for that exponent, it ends up being a negative 12 times 15. That's the only difference. Let's change those few values. And again, I've worked this out already on my side calculator here. So you're welcome to check your steps with that if you'd like. And that ends up being $15,299.87 every month. So the top one was per quarter, and the next one was per month. And then I've seen some questions have these follow-ups in this phrase this way, so I wanted to do an example of them. It says, what is the, quote, absolute difference of the total interest paid on these 2 loans, and which loan is better? Okay, so first we have to figure out what is the interest paid for each loan, and then we can figure out the difference between those. So the first loan, let's see, on the first loan, they made $47,579.86 payments 4 times a year for 15 years. So let's see, 4,7,579 times 4 times 15 gives us $2,854,740 repaid. But remember, they only loaned $2 million. So if we subtract that off, This is a pretty easy subtraction. It looks like what was interest was the $854,740. That is a lot of interest. Okay, let's see, loan 2. On loan 2, they had to pay back $15,299.87 every month, so 12 times a year for 15 years. So let's see, how much did they repay on that? So 15299.87 times 12 times 15. So let's see, that's $2,753,976.60 repaid. Take off the $2 million loaned. So they paid this time $753,976.60 in interest. So I can already tell that loan 2 is better because there's less interest for that one. And when they say absolute value or the absolute difference, that just means subtract in either order that will make this a positive number. So let's take this number subtracted this number. So if we take the 854,740 and subtract off 753,976.6, then the absolute difference is $100,000, $763.40. Very hard to keep saying those very, very large numbers. But that's all they mean in the absolute difference, is just to subtract in the end whichever way makes sense to keep your value positive. So definitely they should choose the second option of this loan. It saves them over $100,000. But in the grand scheme of things, both of those are going to be, both of those are very big loans to take out and take very big repayments to pay back.